Okay, so let's start our today's lecture. And in our previous lecture, in our previous class, just wait a moment, let me. So in our previous class, we talked about the linear equations, right? We talk about the linear equation. And we talk about the linear equations, that how we get the solution of the linear equation. And in the linear equation, there were two things. One was direct method, and one was direct method. And the other one was indirect method. So indirect method. So we just talk about the direct methods. In direct methods, we talk about the matrix inverse method, matrix inverse method, or a simple matrix method. And then we talk about the Gauss-Jordan method. And in Gauss-Jordan method, there was partial, first is no pivoting. Then there was partial pivoting. And then there was no pivoting and completely lead pivoting. So we talk about this one. And in homework, maybe you guys already submitted the homework, or maybe it's there's still there is a time. Gauss-Jordan method. Okay, so I think the last day to submit is this Sunday, or what? Maybe this Saturday. I don't know exactly, but yeah. So we talk about these things. And do you have any question regarding in this one of these methods, or any of these methods? Any issue? No issue? Okay, if this is the case, if there is no issue, then let's move on to the other thing. Okay, so now we will go with the indirect methods. And indirect methods, we also call it the iterative methods as well. These are iterative methods as well, like methods. So in iterative methods, we will be focused on the two methods. One method is Gauss-Jacobi method, and then Gauss-Seidel method. We're going to talk about these two things today. Okay. So let's move on to our this one. So we will start our first with an example of the Jacobi's method. So number one. Jacobi's method. Actually, in Jacobi method, we will have several iteration. We will assume solution of the your linear equations, and we will put the different values one by one. And it is a time-consuming method. It is long method, but it is very easy compared to the other methods. So we will not waste our time on learning the methodology. We will just go through one example, so that will explain everything. So our first question is question number 1, example number 1. Our first example is use Gauss Jacobi method to solve the following linear system of equations. Okay, so our equations are 8x minus 3y plus 2z is equals to 20. Our second equation is 6x plus 3y plus 12z is equals to 35. And the third equation is 4x plus 11y plus minus z is equals to 33. Right? So we have three equations. Equation number 1, equation number 2, and equation number 3. Because there are three unknown variables, x, y, and z, so we have three equations as well. So the first step is you have to make the matrix AX is equals to B, the coefficient matrix. So if we talk about the coefficient matrix, let's talk about the coefficient matrix. What is the coefficient matrix? A is equals to 8 minus 3, 2, and in here 6, 3y, 3, and 12, and 4, 11, and minus 1. So in Jacobi method, the first step is you have to check one condition. What is that? What condition? So you have to see the pivoting elements or diagonal elements. You have to check the pivoting elements. Or for example, you can write it's like A1, A22, A33. Or in here it will be like A12, A13, let's say, and A21 and A22, A23, and finally in here A31, A32, right? So this is our coefficient matrix. So in here we have to check one condition. What is that condition? A11, the magnitude of A11 should be greater than magnitude of A12 plus magnitude of A13. This is one first condition. What is second condition? A22 should be greater than A21 plus magnitude of A23. And A33 should be greater than A31 plus A32. These three conditions, if a matrix holds these three conditions, then we can solve our matrix, or we can solve our equations of system or linear equation with the help of the Jacobi method. But in this particular example, let's see these conditions are okay or not. So in the first one, in here, A11 is 8. The magnitude of 8 is greater than the magnitude of A12 and A21, right? This condition holds in for our particular, okay, wait. So like you guys have, if you guys have any question at any time, just let me know, okay? Because I am not looking at the chat box. So if you guys have any question, just talk to me. Okay, so what I was talking about, we were talking about this one. Okay, so let me change the color. Okay, so in here you can see that A11 is 8 and A12 is -3. So magnitude of -3 is 3 and A13 is 2. So 3 plus 2 is equal to 5. So this condition holds. But in here, this condition is not hold because A22 is 3, and A21 is 6 plus A23, 12. So this condition is not satisfied. And similarly, this condition is not satisfied as well. In here, -1 is, the magnitude of -1 is 1, and this one and this one is 4 and 11. So 4 plus 11, 15. 15 is not less than 1, right? So what we have to do? So now we have to rearrange our equations, or we can say that rows. So for example, in this particular example, if I write my matrix in my equation in this form, so now I will write my equation like 8x minus 3y plus 2z is equals to 20. This one was okay. And now what did I do? I put 4x plus 11y minus z is equals to 33, and then 6x plus 3y plus 12c is equals to 35. So what did I do? I interchange this one. For example, if I interchange these two, then maybe it will hold the conditions. For example, okay, let me write this matrix again. So the previous matrix was 8 minus 3 and 2 and 6, 3, 12 and 4, 11 and minus 1. This was my previous one. But now what did I do? I interchanged. Them. Now my new matrix is 8 minus 3, 2, 6, 3, oh sorry. And now 8 minus 3 and then 4, 11 minus 1 and then 6, 3, 12. Now see the conditions. A11, the magnitude of A1 should be greater than the magnitude of A12 plus A13. So it is okay, right? And then A22 should be equal greater than A21 plus A23. What is A22? It is 11, A21 is 4, and 1. This is 1. So this also holds. And then finally, A33 is equals greater than A31 plus A32, right? A33 is 6, is greater than, sorry, this is 12. 12 is greater than 6 plus 3. So now all the three conditions are satisfied. So I can start moving with the Jacobi's method. So now what is your second step? Step number 2. Your step number 2 is you have to get the values of x from here, y from here, and z from here. From equation number 1, you will get the value of x. From equation number 2, you will get the values of y. And from equation number 3, you will get the value of z. So let's see. From equation number 1, I can write it x is equals to x is equals to what? I can write 20 minus 8, sorry, not 8, 20 minus plus 3y minus 2z and divided by 1 by 8. I can write it in this way. Similarly, the value of y that is coming from here, y will be equals to 1 by 11 into 33 minus 4x plus z. And finally, the value of z will be equals to 1 over 12 into 35 minus 6x minus 3y. Okay, so now we will have 1, 2, and 3 values in here. In step number 3, what you're gonna do, you're gonna put the value of x, y, and z equals to 0. So you will say put x is equals to 0, y is equal to 0, and z is equal to 0, which we say an initial condition values. So what did we do? We put the values of x, y, and z equals to 0. And now we will put in the first iteration. Okay, so this is your third step. And now step 4. In step 4, we will start iteration. So in first iteration, step 4 will be your iteration step. So I will say that I will just write in here, like it is my first iteration. If this one stands for number of iteration, okay? This is not the power. So in first iteration, you will put the value of x, y, and z is equal to 0. So for x, put the value of y and z equals to 0. So x was 1 over 8, 20 plus 3y minus 2z, right? So if I solve it, 1 over 8 into 20, this one will be 0, this one will be 0. So my answer will be equals to 2.5. Okay, we agree on it. Is it correct? Is it correct? You guys can use the calculator and check, okay? So let me know if there is any error. Okay, so we have already x. Now we will go with the y. The first iteration of y, it will be equals to, like we already get the value of y, it was 1 over 11, 33 minus 4x plus z is equals to 1 over 11 into 33. This one and this one is 0. So the answer is what? 3. And then z first iteration is equals to, the first iteration of the z, it will be equals to 1 over 12 into 35 minus 6x minus 3y is equals to this one, and this one will be 0. And then it will be 1 over 12 into 35. Okay, so the answer will be 2.12. So can anyone tell me the answer? Like the decimal? Can anyone tell me the answer? Okay, let me see. 2.9167. Okay. So one student said its value is 2.1, 2.9, sorry, 2.916 and 7. So this is the value. So this one was my first iteration. And let's say iteration first. And now I will start second iteration. In second iteration, I will use this value, and this value to get the value of x, y, and z. Okay. In second approximation, what I will do, I will get the value of x, y, and z from the first iteration, and I will use those values in my second iteration. Okay, let's see. X, second iteration. In second iteration of x, I will use 1 over 8, right? 20 plus 3. Now the value of y will be this one. Now the value of y will be this one because we get it in here. So 3 minus 2. And what is the value of that? 2.9167. So please let me know this answer. Meanwhile, I will solve this one. So the value of y second iteration, it will be equals to 1 over 11, right? 33 minus 4. What is the value of x? Can anyone tell me? The value of x. Now, what value of x we will use here? What value of x we will use here? Yes, we will use the value of x, 2.5 minus, oh sorry, this is plus, and this is z. The z is 2.9167. and here, and then z second iteration will be 1 over 12, 35 minus 6 into x is equals to 2.5, and no, x is equal to 2.5 and y is equals to 3 minus 3. Okay, so what is the value of x in the second iteration? Anyone? 2.89. Can you just tell me 8958? Okay. Tell me up to the 4 decimal places, okay? When you send me. Okay, and this one, the next one, y2. Y2, 2.3561. 2.3561. And next, Z2. What is the value of Z2 in here? 0.91, 0.9167. Okay, so these are 3 values. Okay, so in my first iteration, the value was 2.5. In second, it was 2.8. Similarly, it was 3 and 2.39. It is 2.9, it is 0.9. So we will solve our iteration. We will keep repeating and repeating unless we will have almost same values in our previous iteration, right? So let's go with the third iteration. In iteration number 3, so I would say in the third approximation or the third iteration, x3 will be equals to 1 by 8, 20 plus 3y, so plus 3y minus 2z. So I can write it into like the second iteration, the value of y in second iteration, the value of z in second iteration. I can write it in this way. This is not the power, okay? So make sure this is not power. This is the value of iteration. So in here, I will write it 1 over 8, 20 plus, okay, 3 into y. What is the value of y in second iteration? This one. Okay. So 20 plus 3 into y2. Y2 is equals to 2.3561 minus 2, and the value of z in the second iteration, the value of z 0.9167. And then solve it and give me the answer. Similarly, the y third iteration, it will be equals to 1 over 11, 33 minus 4x second iteration minus z second iteration, and then z third is equals to 1 over 12, 35 minus 6x second iteration minus 3y second iteration. Okay, so in here 1 over 11 and the value is 33 minus 4 into 2.8958, right? And plus the value of z, value of 0.916. Okay, and then finally 1 over 12, 635 minus 6 into 2.895, sorry, please, 558 minus 3 into 2.356. What was the value? 0.3561. Right? And okay, so tell me the answer of this one, and this one. Okay, x3 is 3.1544, 3.1544, and then y3 is 2.03, 2.0303, and z is equals to 0.8797. So this is iteration 3 as already done. So now let's compare. So in here it was 2.95 and in here it is 3, right? So still there is, these are not similar. So we have to go through another iteration. So let's go to another iteration and we'll say iteration number 4. So in iteration number 4, I would say x iteration 4 is equals to 1 by 8, 20 plus 3y iteration in the third minus 2z iteration in the third. And y4 is equals to 1 by 11, 33 minus 4x iteration 3 minus z equation or iteration 3. And then finally z iteration 4 is equals to 1 by 12 and 35 minus 6x raised to power 3 minus 3y raised to power 3. So I want these 3 values. Give me these values quickly. Give me these 3 values, please. Yeah. 3.0414. 3.0414. What is the value of y4? One more student, please confirm me that it is correct. 3.0414. Is it correct? Anyone else? Okay, y4 is equal to 1.9329. 1.9329. And z is equals to 0.8319. 0.8319. Okay, x4. Okay, it is confirmed. Z is also confirmed. Can anyone confirm the value of y4? One more student at least. Z4 is confirmed from two students, and I think today the students are not active, right? You guys must be tired there. One more student, please. Tell me the value of y4. So we will compare the two values from two students. I'm still waiting. 1.7729. Y4. Two students get 1.77 and one student 1.932. Another student. Okay, now it's my time to calculate it. Okay, so we have issue in this one. So y4. Let's try the value of y4 in here. So it should be equals to 33 minus 4 into x cube. X cube is 2.0303 minus z is equals to z cube 0.8797 into 1 by 11. It should be like this one. So where is my calculator? I will calculate. 33 minus 4 into 2.0303 minus 0.8797 and bracket close. Divided by 11. Okay, 1 by 11, 4x3. x3. Okay, maybe this one is not correct. 4 into x3, 3.1544. Okay, let's see again. 4 into 3.1544 divided by 11. 1.77. 1.77. I get 1.77. I get this value in here. 1.77 with using these values. 8797. I get 1.77. 7729. Okay. So next, go with another iteration. Iteration number 5, and let's use this one. So in iteration number 5, we will use x raised to power 5, not raised to power fifth iteration. It will be equals to 1 by 8, 20 plus 3, y iteration number 4 minus 2z iteration number 4, and x y5 is equals to 1 by 11, 33 minus 4x iteration number 4 minus z iteration number 4, and then z is equals to 1 by 12, 35 minus 6x iteration number 4 minus 3 y iteration number 4. Okay, so now give me the values in here. Give me the values, please. So what is the first value in here, and in here? X5 is 2.95. 95 and 9.68. 68. And then Y5, what is Y5? This Y5 is 1.8184. 1.8184. And then Z5, 0.9127. Can anyone else tell me the value of Z5? The value of Z5, please. 0.95, 0.9527. 0. Yeah, like 95 is okay. 91995 or 0.9527. Okay, so whatever is correct, maybe this one, I don't know. Y4 shouldn't be plus the Y4. Y4. I think for the question in answer should be positive side. Okay, so Y4 should be plus Z3. In here, okay, in here it should be, it is my bad. It is, so it is plus as well in here. Let me see. Yeah, it is plus. It is plus. It should be plus, and then it should be plus. everywhere it should be plus. So it's time to raise this one and raise this one. And then put the values in here, like you can say plus in here and plus in here. Okay, so in here, I will calculate it 2.03. It was correct. 33 minus 4 into 2.8958 bracket close plus 0.9167 and divided by 11. 2.0303. It is correct. And then this one is okay, this one is okay, this one is okay. And in here, let me calculate this again. And 33 minus 4 into 3.1544 bracket close plus 0.8797 and divided by 11. It is 1.932. This is correct. This is not correct. This one is not correct. This one is correct. Okay, and what else? So this one was correct, and in here, this one is plus as well. This one is plus, and then the value of x5, it should be the value 0. The value of x5 should be equals to, let me erase it, erase the values. Okay, now try to calculate it again. This value is 20 plus 3 into 1.932 bracket close and this and x5 3.010414, and this value y5 is equals to 1.9696, and then this value of z5, it should be equal to 0.91 9158. Okay, so we are getting closer. So let's see 3.15, this one. Now you see in this iteration and in this iteration, the value of x is almost same, almost same. No, 0.4, it should be like something 3 point, actually this one is 3.0168. So 168. It should be like this one. So now you can see the value of here, the value in here, and the value in here. These keep changing. They are getting closer and closer. Maybe if you go with another iteration, go for another 3 to 4 iterations to get more pre-values. Okay, so you can just stop until here, like iteration 5. It will be time consuming, but somehow you will get the values in here. So maybe if you put the value of in here, x is equals to 1. Oh, sorry, x is equals to 3, y is equals to 2, and z is equals to 1. If you put the value in here in this equation, somewhere here, so it will be satisfied, and then you can say that we were really closer. Somehow we get the idea, and then put the values and you will get the answer. So is it clear to everyone? Okay, so this thing is clear to everyone, and then let's move on to another question. And another method. So our next method, it will be the Gauss-Seidel method. In Gauss-Seidel method, it is not that much time consuming. It will be easier for you guys. So the method is almost same, but there is a very small difference. So that difference we're gonna talk about. So let's start with one example in here. So example number 2, we will say Gauss-Seidel method. So it is the part of indirect method. This is the part of indirect method. So in here, the example, they say that solve the following equation linear system by using Gauss Seidel method. And our equations are 8x minus 3y plus 2c is equals to 20. Our next question is 6x plus 3y plus 12z is equals to 35. And our next is 4x plus 11y minus c is equals to 33. So these are our three equations. And then again, ax plus b, and our coefficient matrix is equals to 8 minus 3 and 2, and 6, 3, 12, and 4, 11, minus 1. So we have to see the three conditions. What are these three conditions? A11, it is greater than the sum of this one, correct. And A22, it is not the case. It is not the case that the sum of this and this is not is greater than this one, and same is the case. So what we're gonna do, we're gonna interchange these two rows again. So let's try to change this one. So it will be So we will just interchange these two values, and then our matrix, it will be like 4, 11, -1, and 6, 3, and 12. Now all the three conditions are satisfied. Now I say this is my equation number 1, this is my equation number 2, this is my equation number 3. Okay, so now I interchange and put the values. Now my three conditions are satisfied. So again, in first step, what I'm gonna do, the value of x, y, and z. I will find the value of x, y, and z. My x will be equals to, from this equation, my x will be equals to 1/8, 20 plus 3y minus 2z, and my y is equals to 1/11, 33 minus 4x plus z. And my x, y, and z. My z value is equals to 1/12, 35 minus 6x minus 3y. I put the values in here. And in here, the only difference is, for example, in here, in the first method, like what the name, the previous method, we give the value of x is equal to 0, y is equal to 0, and z is equal to 0. We start these initial values. Okay, so same this thing, we will start this one. Okay, so in here I will say my x1 in the first iteration, this is step 2. So in my first iteration, x1 is equals to 1/8 20 plus 3 iteration 0. Iteration 0 means the value is 0. Okay, and plus minus 2z in iteration 0. Okay, so what I'm gonna write, 1/8 and 20 plus 0 plus 0 is equals to 2.5. Now y iteration 1. In y iteration 1, what I'm gonna do is that 1/11, 33 minus 4, and there is x, right? So I will not use the value of x0. I already calculated the value of x in here, right? So I am gonna use 4x1 minus, plus z in the 0 iteration. 0 is means in iteration, initial iteration, it will the value of x. Earlier, what we were doing, we will putting the value of x, y, and z in all the three. In here, and in here. We put the value of 0, 0, 0, 0, 0, 0, and 0, 0, 0, and then we find the value. But in here, what we're gonna do, we find the value of x. The initial condition will be the same, the 0, 0, 0. So considering x is the y and z is equals to 0, we calculated the value of x. Now we already have the x1, the first iteration. So put this value of x1 in here. And now we put in here, so 1/8, 1/11 into 33 minus 4, x1 is 2.5 plus z is equal to 0, right? So can you calculate the value of this one and let me know? Please, please give me the answer of this one. 2.0909. And similarly, we will go with the Z1. Z1 is equals to sorry. Sorry, I will just write in here. Is Z is equals to 1 by 12 and 35 minus 6x integral 1 and minus 3y integral 1. So its value will be 1 by 12, 35 minus 6. X is equals to, X we already calculated 2.5 and minus 3, Y calculated 2.0909. And then calculate the value and write in here. Can anyone tell you? 1.1439. 1.1439. So this is the value of Z. Okay. So now iteration 2. In iteration 2 again, X iteration 2 is equals to. Now we will use the most recent values. 1 by 8, 20 plus 3 iteration, sorry, y1 minus 2z1 and y2 is equals to the second iteration. It will be equals to 1 by 11 bracket 333 minus 4x in iteration 2 plus z in iteration 1. Because we don't have the value of z in iteration 2 yet. And then z2 will be equals to 1 by 12, 35 plus or minus 6x in iteration 2 minus 3y in iteration 2. And thus the values. Can anyone tell me the values? Okay, I will write it 0.9141, this value. And then y2 should be equals to 2.0137. And x2 should be equals to 2.9981. Okay, so once you solve this question, please make sure you use the 4 decimal places. Okay. I will just write in here. So please use 4 decimal places when you solve this type of questions in the iteration 1. Okay, so this is iteration 2. Similarly, in iteration 3, x3 will be equals to 1 by 8, 20 plus 3, y iteration 2 minus 2, z iteration 2, and x y 3 will be equals to 1 by 11, 33 minus 4 x iteration 3 plus z in iteration 2, and z is equals to 1 by 12, 35 minus 6 x3 in equation 3 minus 3 y in equation 3. Okay, so can you tell me the answer of this one? Can you tell me x in the equation third? So let me write 3.0266 and 1.9825 and 0.9077. So these are the values. And next, in iteration 4, you will keep doing this repeatedly. Keep doing the trails until the values of x, y, and z are close to their previous creative values. And then that's it. That's end of the example. Okay, so keep doing this 3, 4, 5 iteration, and then finally you will get the one answer. Is it clear to everyone? Let me know if you have any questions. If you have any question, let me know, and then we will start our next topic. No question? Okay, so I guess everything okay. And then let's move on to our next topic. Our next topic is about the eigenvalues. So our next topic is about the eigenvalues. Or eigenvectors. So let's say we have a matrix A, which is given by that you can say that A11, A12, A21, A22. So the equation, wait, this equation, okay. So we can write it A x is equals to lambda x, or we can write it, take this one in here, and then we can say that A minus lambda is equals to 0, null matrix, where 0 stands for null matrix, lambda is eigenvalue, I is identity matrix. Okay, so in here, lambda is known as eigenvalue or vector value. If we put it equals to 0, then we call it eigen equation, or the we can say that the characteristic vector, or polynomial, we can say in any way. Okay, so the in first step we have to find the eigenvalue lambda, and sometimes the values are more than one. So when the values are more than one, there will be more than one equations. For example, we will have lambda 1, lambda 2. So our equation will be A minus lambda 1 I is equal to 0, and then A minus lambda 2 I is equal to 0, right? We will have two lambda values, and for each lambda values, there will be a eigen matrix, individual eigen matrix for each eigenvalues. Okay, is it clear? So again, this is eigenvalue, or we can say it eigenvector, or we can say that root value, and anything we can say. And once we put this value back in this equation, we call it the characteristic equations, or we can say that the polynomial. Okay, this one will be polynomial, but if we put it equals to 0, then it will be the characteristic equation. So in question, they can ask you, please find the eigenvalues or eigenvectors plus the characteristic equation of for this particular matrix. Okay, so from this one, we will start our the question number 1, considering this one. So question number 1 is, find the eigenvalue of the matrix. The matrix is given by 8 minus 6, 2, minus 6, 7, minus 4, and 2 minus 4 and 3. Find the eigenvalues. Okay, So to find the eigenvalues, what we're gonna do, we will write this equation. The determinant of A minus lambda identity matrix, we have to find this one. Okay, so we can write it, for example, this is our A. A is equals to 8 minus 6, 2 minus 6, 7 minus 4, and 2 minus 4, and 3 minus lambda, and 1 0 0 0 1 0 0 0 1. Or we can also write it in this way: 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 minus lambda 0 0 0 lambda 0 0 0 lambda. Or we can write it in this way as well: 8 minus lambda minus 6, 2, right? 8 minus lambda minus 6 minus 0, 2 minus 0. So I will just write in this way. So minus 6, 7 minus lambda, and minus 4, and 2 minus 4, and 3 minus lambda. Okay, so we have to find the determinant of this one. The determinant. Okay, so how you will find the determinant of this one? Can anyone calculate the determinant of this one? Anyone? Okay, so it is easy, like, to calculate the determinant. Determinant is equals to, for example, just move this one and this into this and this. So it will be equals to 8 minus lambda, 8 minus lambda into 7 minus lambda into 3 minus lambda minus 16. This is plus, and then minus 6 minus 6. Oh, okay, plus minus minus plus 6 into minus 6, 3 minus lambda plus 8, and plus 9. Wait, I should not change the. Okay, I will just write the values in here so it will be easier for me. Okay, so this one and this one. So 8 minus lambda into this, 7 minus lambda, 3 minus lambda minus 16. Okay, so this will be my plus, and then next is our minus. So this, and see, I will remove this minus, it will be plus 6, and in the bracket as minus 6 into 3 minus lambda minus 8, it will be plus 8. and my next is plus, and this one is plus 2, and it will be equals to 24 minus 2 7 minus lambda. Okay, so please solve this one and give me the value of lambda, please. Everyone solve it and give me the value of lambda. This is the simple things. Just try to solve it. Try to solve it and give me the final value of lambda in the equation. We will equate it to 0 later, but right now we will just get it the value of lambda, and not the value, the equation, the most simplified equation. Just open these brackets and solve it, and then multiply, division, and everything, and then give me the value of the final equation things. Please, everyone, try to solve it. It is not that difficult. Yes, yes, yes. Just the expression with the lambda. It should be something, because there is 1 to lambda cube until there will be a lambda cube. Okay, I will also solve this one. 8 minus lambda, and in bracket 21 minus 7 lambda. minus 3 lambda plus lambda squared minus 16 plus 6 into minus 18 plus 6 lambda plus 8 and plus 2 24 minus 14 plus 2 lambda and further 8 minus lambda will be equals to 16 21, it is 5. It will be equals to 5 minus 10 lambda plus lambda squared, right? Plus 6 minus 10 plus 6 lambda. And this one will be equals to plus 2. 24 minus it will be 10 plus 2 lambda and 8. Okay, so multiply it with inside, so let's say 40 minus 80 lambda plus 8 lambda squared minus 5 lambda plus 10 lambda squared minus lambda cube. Okay, plus 6. This will be minus 60 plus plus 36 lambda plus 20 plus 4 lambda. Okay, so one student, he sent me that minus lambda cube. One student sent me that if we this one minus lambda cube plus 8 lambda squared plus 18 lambda squared and minus 41 minus 45 lambda. Okay, so maybe it is somehow it is correct. This one. This one is correct. This one is correct. So if you want to see that your equation, this equation, it is correct or not, so there is one thing. So check the coefficient of lambda square. Check the coefficient of lambda square. It should be equals to sum of this diagonal. 8 plus 17, 8 plus 7 plus 3. It is equals to 18, right? So it should be equals to like this one. And other thing is there is no coefficient, right? So there is lambda, lambda, lambda. There is no coefficient, right? So determinant of A will be equals to 0. If you take the determinant of this matrix, then it will be equals to 0. Can anyone calculate the determinant of this one with using your calculator? You have matrix in the calculator. If any one of you can calculate the determinant, you can get the determinant of this one. So Now we will have lambda cube is equal to lambda cube minus lambda cube plus 18 lambda squared minus 45 lambda is equal to, and then let's put it equals to 0. Okay, so our equation is minus lambda cube plus 18 lambda squared minus 45 lambda is equals to 0. So take the lambda, what you say, that common, and then you can just take the minus lambda as a common, and then you can write it like minus lambda cube squared minus 18 lambda minus sorry, this one will be plus 45 is equals to 0. So can anyone give me the values of lambda from here? Lambda is equals to, okay, anyone else? Lambda is equal to 0, 15, and 3. Okay, also 0, yes, 0 is included as well. So lambda value will be equals to 0, 3, and 15. What happened to my computer? Okay, 0, let's say lambda 1 is equal to 0, lambda 2 is equal to 3, and lambda 3 is equals to 15. So these are 3 lambda values. So for each lambda value, we have to find now the characteristic equation. So how you will calculate the characteristic equation? Put back the lambda values in here. First put the lambda is equal to 0, then put lambda is equals to 3, and then 15, and then find the values. So let's try to solve this one. So in the book, it is a bit difficult method, or it is confusing, but the way I will solve it in here, maybe it will be easier for you, and it is quick as well. So make sure you try to solve this question like the way I am solving it here. Okay. Okay, so these are the lambda values, lambda 1, lambda 2, and lambda 3 values. So I will write back the matrix A. So my matrix A was my matrix A was 8 minus 6, 2 minus 6, 7 minus 4, and 2 minus 4 and 3. And then my equation was A minus lambda I is equals to 0. This one was my equation. So we will put lambda values one by one and try to calculate in here. Lambda is equal to 0, lambda is equal to 3, lambda is equal to 15, and we will solve it one by one in here. So there is a very easy way you can solve it. So what we're going to do for lambda 1 is equals to 0. So we will write it in here, a minus lambda I is equals to 8 minus lambda. We can write it in this way, 8 minus lambda minus 6 and 2 minus 6, 7 minus lambda and minus 4 and 2 minus 4 and 3 minus lambda. We can write it in this way. Okay, so now what you're gonna do in here, it is very like better method to calculate the equations from here. Okay, so in here, a minus x is equals to this one, and a minus this one, 8, 8, 8. Just 1 minute, please. We will write it in here. O lambda is equal to this one. We will write the matrix A and then 7 and minus 4 and then 2 minus 4 and 3, and then we will give the value because we are going to make the characteristic equation, and then we will write x1, x2 and x3 is equals to 0, or we can write it 0, 0 and 0. Okay, so this one will be our value. Okay, and then let's try to, because in here our equation was like x into a minus lambda I is equals to 0. So we multiply it with the x here, and then we have to find the value of x1, x2 and x3 now. So there is very easy method. What you're gonna write, x1, x2, x3. Okay, so for x1, what you're gonna do, just hide this and this one, and take the determinant of 7 minus 4 minus 4, 3. For x2, hide this one and this one, and take the determinant of minus 6, minus 4, 2 and 3. And for x cube and x3, just hide this one and this one, take the determinant of this one. So minus 6, 7, 2, minus 4. Okay, so please tell me the value of this one, and this one. Put the values and calculate the determinant now. Please try to calculate the determinant under x1, x2, and x3. Is it very difficult for you guys? This is small determinant. It is a 2 by 2 matrix determinant. I cannot see any chat now. Okay, so it will be equal to x1 over 7th 21 minus 16 is equals to x2 over 18 plus 8 is equals to 24, x3 24 minus 14 is equals, or we can say that x is equals to x1 is equals to 5, x1 is equals to 5, x2 is equals to x2 by minus, that is equal to minus 10 is equal to x3 by 10 is equal to 0. So we can take the we can write it divided by 5 everywhere. So we can say that x over 1 is equals to we can say that is equals to x2 over just check this one. This one was minus 6. Okay, so this one was minus 2 and x3 over 2. So is it correct? Is it correct? Okay. So make sure your signs are okay. X7373 final and let me 1 2 1 minus 2 and 2. So and in final step what we gonna do, we say x1 x2 and x3 is equals to 1 minus 2 and 2. So this one will be your value and that's it. This one, like you can say that k or you can just write it k. So this one will be your equation. Okay, you guys got it? So this one will give you one equation. So this one will be your characteristic equation. Similarly, if you put the value lambda is equals to 3, and then you will write it like a minus 3i, a minus 3i x is equals to 5 minus 6, 2 minus 6, 4 minus 4, and then 2 minus 4, 0, and then x1, x2, x3, and then equals to 0, 0, 0, right? And then similarly, x1 will be equals to x1 is equals to just hide this one and get the value in here, the determinant in here, plus get the determinant x2 over something in here, plus x3 something in here, and then equals to 0. And then finally you will have x1, x2, x3, and put equals to k, and what the values you will get in here, in here, in here. So this one will be your second characteristic value, and then you will have the third characteristic value as well. Okay, is it clear to everyone? So make sure when you solve this one and minus, there is a 3i. Okay, the value of lambda will be different. Now you have the matrix A and multiply the lambda value with the identity matrix, and then you will get here this one, and this x is equal to x1, x2, x3, and it is equals to null matrix. This is null matrix, and then solve it and then get the value of x1, x2, and x3. That's it. And then you will have lambda 4, 3, and then solve it like in this way again, one by one. Okay, so is it clear to everyone? Okay, let me give you one. Let me give you an example to solve. So, okay, so find a set of 3 eigenvectors for the matrix. Find the set of 3 eigenvalues for given matrix. A is equals to 5, 0, 1, 0, minus 2, 0, 1, 0, 5. Give me the eigenvalues. Okay, so the characteristic equation, like if you want to write the characteristic equation will be A minus lambda I is equals to 0. This will be your characteristic equation. Lambda will be the lambda values. So please solve this one and let me know the lambda values. From here, you can calculate. This is A. You already know I. You have to calculate the lambda in here. So please calculate this one and let me know the answer. Okay, I think it's kind of difficult for you guys to get the lambda values. Okay, so let me try as well. And this is the determinant. So I have the value of A is equal to 5, 0, 1, 0, minus 2, 0, 1, 0, 5, and minus lambda, and I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Or I can directly write it in here. I will just directly write here, just minus the lambda values. So minus lambda in here, minus lambda in here, minus lambda in here. And determinant of this one should be equal to 0. Okay, so one student get the value minus 2, 6, and 4. Lambda is minus 2, 6, and 4. Any other student? Any other student? Okay, the one more student said minus 2, 4, 6. And what else? Anyone else?